Good evening. Welcome to Codebase Alpha. This is episode 44. We're certainly moving along with episodes these days. And this evening we're going to be looking at C++ and JUCE again. So we started, it was last Wednesday, I think it was, when we started looking at the JUCE library, the JUCE framework for producing desktop applications in C++, animation applications in C++, and audio applications. And in particular, we're looking at VST3 audio plugins, which we can use with our DAWs, our digital audio workbenches or workstations. In fact, for those of you who stream, OBS can accept VST plugins as well, but they're version 2, and we can create those as well with JUCE. In fact, we can create version 2 and version 3 at the same time because of the kind of cross-platform and multi-programming styles that JUCE has. So at some point we'll do that. We'll create some plugins for OBS, maybe a vocode or something like that. Those are all kind of things in the future, though. So last time I started out writing a multi-filter plugin. So the idea of this filter was to, or rather this plugin, wasn't necessarily to demonstrate how to build plugins from scratch, but it was a learning exercise. So we were trying to put a GUI together, and then we're going to use some of the classes that come with, not with JUCE this time, but with the FX objects classes, which I got from a book. Now the book is a weighty tome by Will Perkle, and it's called Designing Audio Effect Plugins in C++. And actually with that book, and we're going to be using that book tonight, it's a framework agnostic. In fact, it comes with its own framework, so it's nothing to do with JUCE per se, but it does come with a whole bunch of pre-built algorithms, and that's what we've got in our FX objects JUCE module, which I created from the code that comes with the book. There's a whole load of stuff in that book to do with the framework that the author has created. It's called Aspic. But we're not going to be using that. We're going to be using JUCE, and so we can extract certain bits from that from the code that was created for that book and reuse that in any framework. And it's going to save us a lot of time in the long run to build more complicated audio effects. But so the object of this first plugin is just to get used to kind of building a GUI and connecting the GUI up. And then in the next plugin we do, we're going to build a delay effect, and we're going to build that from scratch. Then we're going to start to bring in some of the pre-built classes to kind of improve it and to simplify our code, and also to kind of take advantage of the performance improvements that are built into the predefined classes. So let's pop over to the code, shall we, and let's see what we can see, because there's a few changes I've had to make to get this thing working, and I wanted to go through what we did to get the combo box kind of wired into the audio parameters, which is the big problem I had last time. So let's go and have a look at that code first. Okay, so here we are in the this is in the plugin editor class. So this is multi-filter audio processor editor. So this is the class which controls basically controls the GUI. So this is going to run on a completely separate thread from the audio processing. So we're in a multi-threaded paradigm here. The GUI is going to run on one thread and the audio processing on a separate thread. And the audio processing is the thread that always has priority. So the GUI one, it has to kind of wait. So we got as far last time as having a lot of difficulty with this combo box. So you can see we've got this filter type combo box here, and what I was trying to do was wire it up to an audio parameter called audio parameter choice, which seemed to promise the idea that you could put in all the various choices of the combo box and manage the combo box content through that. But it didn't work. We didn't get any choices, any options in the combo box. But what it did seem to get is that even if I had no choices in there and some choices which added to this kind of item list method, then we did seem to have some connectivity, but it was a bit kind of hard to work out exactly what was going on. Actually, I'm going to put some music on because I think this is something where we need some music. Let's have some Relax Daily. There we go. And we're going to use the Relax Daily at some point as well to demonstrate some of this code. Okay, so what I've done is first I've added all of the different filter types that our plugin is going to support to this combo box. I've still got exactly the same code as I had before, so I'm connecting it up here with this combo box attachment to the filter type control. Okay, and its filter type value is here. So this is a pointer. Filter type value is a pointer to this this combo box attachment. Okay, and the ID is filter type. So what the difference is, rather than using a combo box, I've actually connected this up to so rather than using an audio parameter choice, I've connected it up to an audio parameter int. And this was the kind of solution really. And it took quite a lot of kind of searching around in the literature really on the internet to find out that this would actually work. So what we've done is, rather than an audio parameter choice here, the filter type parameter is actually now a pointer to of type audio parameter int. Here's the ID filter type, which we saw back in the editor here, filter type. So that connects the two together. And what we said is that it ranges from 1 to 29. So basically what happens here is, if you choose option 1, the first option, which is low pass filter 1 pole, LPF 1P, then that parameter will be 1. If I choose this one here, imp inv LP 2, it's going to be 29. So that's the idea. And the default selected item is going to be number 1. So the first option. So that's the first of the changes I made. So I believe that's going to work. It certainly indicates in the documentation, not of audio parameter choice, but actually of the combo box attachment, that should work. Cheers everyone, by the way. Okay. The other thing I did back over in the editor here, as you'll remember, we struggled a bit with the layout of the GUI. So I did a little bit of research into layouts, and I found there's a couple of things we can actually do to improve that. There is the concept of a grid and also a flex box, and these concepts are taken really directly from CSS really. Now, as I've not really had any dealing with flex boxes in CSS, I decided to use a grid. So here is the layout that we've got in our resized method. We create a grid, and then we have rows and columns. So we have a single row currently. We have four columns. There's 3 equally spaced columns here, and then 1 double-sized column. And then we basically add our items to the GridItem property here, and it will distribute these items across our grid as required. For the filter type control, we've specified a height and a width. It also had it so it aligns itself and justifies itself within the box. Okay, so we can now run that up and have a look what it looks like. So I did something else actually, just to make debugging this a bit easier. I made multi-filter shared code the startup project, and also I went into properties, and under debugging I set the debugging command to be the audio plugin host, so that basically what happens now when we run this project from within Visual Studio, we actually run the audio plugin host automatically. So it will compile this and it runs up our host, and you can see here's our multi-filter here, and I can double click on it, and here's our UI. So we've got our cutoff frequency dial, our Q factor dial, our that's our feedback. We need to have some more information on that feedback in decibels. Okay, and then we have our combo box with our different types of filters. You can see that out of the box, using the FX objects JUCE modules I've created, we're going to get all these different types without having to kind of worry about how they work. We're going to come back to filters either later today or in another stream, and I'll explain how a very, very basic filter actually works. And we can look at the kind of algorithms of these at leisure, really. But when we understand how a very, very simple filter works, all the rest of these things are really just variations in different algorithms. So let's shut that down. Okay. So I think there's a couple of things I want to do before we go much further. And one of them is, I'm looking at this code and I'm thinking there's an awful lot of repetition here. And what I want to do is tidy it up a bit so we haven't got quite so much repetition. So what I want to do is create a make rotary slider method or function. So let's go and do that. So let's go to our plugin editor.h, and we're going to create a new method here. It's going to be void, and it's going to be called make rotary slider. Rotary, make rotary. Yeah, slider. Okay. So what's that going to take? Well, it's going to have to take a slider, a pointer to a slider, isn't it? So it's slider. We'll just call that the slider. It's good. So if we go back to plugin editor, you can see that we have this. This label, this suffix here, which comes after the pop-up display of the value. Ancient Coder, good evening, welcome to the stream, good to see you. Thank you for joining. So we're going to need that text there passing in. And the only other thing is, on the pop-up display, there's actually a parent component here. You can see a JUCE component, parent component to use. So we're going to need to pass in a parent component. So let's create that. So there's going to be a string, which is going to be a suffix, and then there's going to be a component, a pointer to, and that's going to be the parent. So I think that should suffice. Let's save that over here and then go back over here. So let's try this out. So we want to make rotary slider, and we're going to pass in cutoff frequency. So this is going to be cutoff frequency control, and then it's going to be that text there, cutoff frequency. And it's going to be this. Oops. Being the parent. So this here is has it got to be that? I believe it has. There we go. So we're passing in a reference to our control. So that should mean we should be able to get rid of these lines of code. So let's just comment those out for now. Okay, we still need this one here where we're linking up to a slider attachment, and then we've got to make visible. I wonder if we could interesting, add a make visible may be able to go in there as well. So let's recompile and make sure that still works. Okay. Oh, what happened here? does that need to be that as well? No? Should just be that, I would have thought. This isn't got to be a star, is it? No. So I'm pretty sure that's correct. Let's try building again. I'm not sure what that message is trying to tell me. This is one of the problems when you start out with a new programming language, that sometimes the error messages don't seem to exactly make an awful lot of sense initially. So this is telling me unresolved external private void. Oh, okay, so I'm not calling it correctly, am I? So I need to actually I need to actually define it. So I haven't even defined it yet, have I? That's why it's saying unrecognized reference. Okay, so let's create it down here. So this is going to be multi-filter audio processor editor : and then it's going to be make, what did I call it? Make Rotary slider. In fact, we can just go to the editor here and grab the definition of that. That's that definition there. And then over here, that's void. Okay, so now what we can do is actually we can pinch this code here, commented out, and just pop that in here. And this can become slider. And this is going to be suffix. And this is going to be parent. Okay, what's it saying here? Expression must have class type. Is it supposed to be like that then? Yeah. So it's a pointer, so we have to point to its member methods. Yeah, that should solve that. There we go, pointer. Okay, let's rebuild that and make sure that builds okay. So welcome everybody, good to see people in chat. So we're having another adventure into C++ here. I built this time, good. Okay, so let's once again we've commented out that the code that produces the cutoff frequency. So let's run up our debug, and we've still got a nice rotary slider. So we've gone a bit drier with our code now. So we can now kind of group these together a bit and get rid of some of this repetition. So next we're going to have just grab this line, and this is going to be Q factor control, Q and this lot can go. We got the same thing again. This is going to be boost control, and this is going to be feedback decibels. It's a bit more expressive than just decibels, so we can get rid of those lines and that line. And then we've got our combo box, which has been defined there. So let's just rebuild that and make sure everything's happy. Evening, Cody Beard. Good to see you in chat. Thank you very much for joining me. So the plan for this evening is to try and tie up this multi-filter plugin, which is just our learning plugin, really, our way of trying to working out how to wire up a GUI to something that which actually does something. We're going to use all of the built-in features of the FX objects module, which I created with all our built-in algorithms. So we're not going to do things from scratch. We're going to use all that, and we're going to demonstrate what a filter does. And then we're going to kind of take a step back, and we're going to create a delay effect, and we're going to do that from scratch, and then eventually start to bring in the built-in classes that we've got to make it better. Okay, so if we run that in the debug again, and we've still got all of our controls, and we got feedback this time. db q is a I believe a unitless value, and cutoff frequency, that should say hertz, shouldn't it? So let's just fix that. Cutoff frequency in hertz. Okay. So we've got those bits working, and we've got a basic kind of layout here, but I do want to kind of do a bit more with this. So we've got, let's have another row like this. That's 2 rows now, and the columns are the same, and the first item in our grid, so what should we make that? I think it needs to be the name of the plugin that we're working on. So let's go over to here, and let's create a label called plugin name. Okay, and then over here we'll have plugin name dot set text. Is there set text? Yep. So that's going to be codebase alpha multi filter, and we need to make that visible. So add and make visible. We can pass in a reference to that label. So that's going to be plugin name C#. Fritz is hosting. Thank you very much, C# Fritz, for hosting the stream. That's very kind of you. Okay, so we've got that. Oops. We got that in there. Let's see if we can make that visible on our layout. So the first item in our grid is going to be GridItem and it's going to be plugin name. And I wonder what we can do with it. We should be able to make it column span. So with, can we make it column span? With column, start and end property. Start and end property. So we need to find out what a start and end property is. Let's go over to our JUCE documentation. Rambling Geek, welcome to the stream. Good to see you. Just trying to do a favour for a friend and getting a little stressed. Oh dear. Well, don't get too stressed. Yeah, I'm fine, thank you, Cody Rambling Geek. I'm actually on holiday now from 2 weeks from work, so I'm hoping to going to be fairly chilled by the end of this week. It's still a bit kind of tense at the moment. So what were we looking at? We were looking for start and end. Looking for something called start and end property. So let's find that start and end property. So this is one of the kind of issues when you started out with working on a new framework and a new language. Okay, so start and end property. Property start, property end. So what is a property? Number to use. Span. Okay. So it'll take in a span apparently. That doesn't appear to say it does it? So property. It's an int. So let's try to use that. It always feels like a lot of guesswork this does. So this is a grid item. Grid item. Start and end property. Can we do that? Property. Is it a grid item property? Okay. Start and end property. Start and end. Okay. Whoops. That's going to be equal to pretty sure we can't do that. Print start and end properties. So property, the grid item property. Property 1. This is never going to work, is it really, a month of Sundays, but we'll give it a go. Let's try it and see what could possibly go wrong. Oh, okay. So set text here needs another value, which is going to be a notification. Okay, these values can be updated, so I'm pretty sure there's something called don't send notification. That's it, yeah. Let's rebuild that. Have a good lurk, Rambling Geek. Hope you managed to fix your problem for your friend. Well, it built. All it's going to actually display is anyone's guess. Okay, so we've got something here, but it's actually fitted. It's not done the col span at all, is it? So obviously, what we're doing is not how you do column span. So let's see if we can find anything. JUCE layout grid column span. I don't think we're going to find anything, so we need to go back to GridItem, I think. GridItem. Okay. With area. Span of 1 by default. I think it's with area we want, isn't it? Let's try that. Down here, rather than with column, with area. We need to remember to build. Oops, no, it doesn't like that. So with area, what's it take? smooth area. Column start, column end, column start, row end, column start, row end, column end. Oh, row start. So, we can probably get rid of all that. And we're going to have grid item dot property colon property 1, which is row 1. Let's put 4 of those in. Let's give that a go. We'll try anything once. Once we've got all these kind of GUI bits sorted out, it's going to be standards in good stead for the future, because I'll be able to just cut and paste a lot of this code and just changing it around, which is okay. So that's actually done it, hasn't it? So that is now moved it across onto its own line. If we make this larger and center it, or move it larger and move it to the top. So let's drop that down and then do a dot with, what did I have here? With a line self. And this could be top. Justify. Justify self center. Let's try that. We won't mess around too much with it. Let's build it again. That's supposed to be justify self. Because we're going to get too. Oops, I don't want to do that. We're going to get too bogged down on the old GUI side if we're not careful. Rebuild that. Though I do want a nice, presentable GUI. Okay, so let's fire it up, and it should now be. No. That'll have to do for now, I think. Okay. So we'll come back to that, tidying up that at some point in the future. But it's got a title now, and we've got. It looks like it is spanning, though. Why it's not justifying, I'm not at all sure. Okay. Right. So let's get our rest of our code done. So we've kind of got a basic GUI working, and we'll leave it at that for the moment. Let's go over to our plugin processor, and this is where we're going to actually do on a separate thread all the audio processing. So if you remember from last time, we set up this plugin state tree. and we populated it here with this create parameter layout. So these are the 4 parameters that we've got control over: the cutoff frequency, the Q factor, the boost cut, and the type of filter we're going to use. So there's a couple of really important methods which are part of an audio processor. The first one is called prepare to play, and this is where we do our initializations. And the second one is a process block, where we actually process data. So we're going to get our digital effects book now and have a look at what we need to do. So we've set up the controls. The next thing we need to do is actually create some audio filters. So over here in the .h file, we're going to set up some values. So we want a couple of audio filters. We want an audio filter for the left-hand channel and the right-hand channel because we're dealing with stereo. So we're going to create an audio filter, and it's going to be called left audio filter. There's another one. Right audio filter. So remember that audio filter is a class which has come along for the ride from the JUCE module I created called FS Objects, which comes from the book we're working from. Okay, so the book basically it gets you kind of started on developing these things, and then gives you a bunch of homework. And it's the homework we're going to actually be kind of doing as the main part of the stream, but we need to kind of learn this framework, and I need to kind of pick up as much as I can of the C++ language while we do this. So let's see what else we need to do now. We're going to need to be able to update the parameters on our filters. So let's start off with an update parameters method and see where that takes us. Okay, over here in our prepare to play, we need to kind of set up those filters. And you set them up with a it's not the right place, that's resources. Prepare to play, here we are. They need to know the sample rate, and the sample rate's here, because everything in digital audio, everything's driven by the sample rate. That determines kind of things like frequencies, and also whereabouts in, say, circular buffers, that you're kind of the size of a circular buffer and how whereabouts you're actually reaching into that. For a filter, it's also extremely important. It's one of the basic parameters, and of course different music samples can run at different sample rates. We're using kind of 44.1 kilohertz, which is CD quality, but it depends on what we feed into this filter. It could have very much different rates. 44 kilohertz, for example, or 96 kilohertz are also kind of popular. Okay, so we've got left audio filter and right audio filter, so let's call a reset on those. We've got a reset function, and reset takes a double called sample rate. So, and you see this is coming from FS Objects.h. You can see here, it's very tiny on the screen, but this audio filter class is coming from the book code. So here we're going to pass in sample rate. Oops. Like that. And same for right audio filter. Dot reset. Sample rate. So before we start playing any audio through the filters, it's going to reset them, and it's going to basically reset the algorithm with the current sampling rate. Okay. We need to write an update parameters method. So let's do that. So void, we want this, update parameters. Okay. So this has to set up the various coefficients or parameters that the filters use. So we need to get the parameters from each of the left and right filters, then update them. So if we use auto, I'm not sure exactly what type it's going to be. So the filter parameters is going to equal the left audio filter dot, and then there should be a get parameters. There is get parameters there. That's going to get us a struct basically of some kind in here. It's a struct of audio filter parameters, as you can see. And that, so filter parameters. And what have we got sitting on this? We've got the algorithm, the boost cut, the frequency cutoff, and the Q. So we can now grab these from our parameters. So the cutoff frequency, so that's going to be equal to. So we want to dereference the plugin state. Remember, plugin state. If we go over to plugin state in here. Is this audio processor value tree state, and that is set up in the constructor. So that's plugin state is created here. So let's in state dot, and there should be a get on here, get raw parameter value. And this is going to want the ID of the parameter that we want. So this is going to be so the IDs are over here. This is going to be cut off. Where did we go with that? Here. Okay. So I think before we go any further, what I'm going to do is place a breakpoint here, and I'm going to call update parameters in our process block here, and I'm going to build that, and we're going to run it in debug and see if we hit that breakpoint. So let's see what happens. We've hit our breakpoint. Let's step through there. So we've got a struct now of these values. These are default values. Okay, so we've got a queue of that. 100 is the cutoff value. And what did we say our default cutoff was going to be? 1,000. Okay, so that's, if we step over this one, this is now equal to 1,000. So we've managed to grab out the cutoff frequency from our parameter, and now we've popped it into the filter there, the filter parameters. So that's pretty convincing that we're actually getting those out there. So let's do the rest of the ones. So there's two more simple ones. So there's Q, and that was called Q factor. And in fact, we don't need these underscores in here. Let's get rid of those, because that's actually a name. I didn't realise that's actually a name, so that can be boost cut, I believe. That should still work. So this was called Q factor. Oops, that's that one there, sorry. And finally we've got boost. Like that, and this is going to be the boost cut decibels, which is in decibels because that's the units we set. So the only other thing to do now is to get the algorithm, which is basically the filter type. So let's get the filter type. That's going to be equal to, and we've got dereference the plugin state. Get raw parameter value. And that was, forget what it was called again, it was called filter underscore type. Yeah. So now we want to set filter parameters. Algorithm. Now the algorithm is of type filter algorithm. So this is an integer, so we're going to need to cast. So it's an enum basically. So we're going to need to cast it. So we can use static cast to filter algorithm. And filter type. So I don't know if that's actually going to work. Static cast expected identifier. Okay. Let's see. Static cast C++. Int to enum. And to cast int to an enum in C++. Static cast integer to enum conversion. Okay. Didn't need the std : in front of it. Yes, it's not in standard. Thank you for your stable. It's a keyword. Yeah, yeah. I keep. I'm having to learn all this. It's knowing when to use the namespaces and not to use them is lack of familiarity with the standard library and what's in there. Okay, so let's put a breakpoint there, shall we? Rebuild it. Okay, and run it up. And we've hit our breakpoint, so let's just check these. That looks correct. Let's just step over here. And our filter algorithm is LPF1. I think that's the very first one in the list. We can soon check that by going over to the editor. Now the LPF. Okay, that's interesting, isn't it? LPF1P is the first in the list. So let's go and have a look at what filter type. Filter type is 1. Okay, have I got them mixed up? Let me just check the list of filter types. That is that's not correct, is it? Let's just stop this a second. Let's take 1 off that just as an experiment and try again. My understanding was it should be 1 to 29, not 0 to 28. Still, we'll find out. The keywords in blue can help me, yeah. Colorization should have told me, shouldn't it? So that's interesting. Looks like we do want to go from 0 to 28, not from 1 to 29. So let's sort that out. So back at the top here, we want to go 0 to 28. It's a bit contrary to the way I read the documentation, but there we go. Just double check that. Step over. And we are at 1. Because I said the default was 1. Okay, that's fine. Let's just change the default to 0. And then we should be good to go. Okay, so what I want to do, actually let's build that and let's make sure that doesn't that makes sense from a plugin editor point of view. So what's this saying? That's the first item offset, so it may be that it doesn't work properly. So let's rebuild and make sure that the GUI lines up. So it should be LPF1P should be the 0th item, but because we've set an offset of 1, we may need to set the offset to 0. Okay, let's start it up. We'll just remove that, continue, double click here. Oh, we're on the right one. Okay, that's fine. Okay, so we've set our filter parameters up. So what we've done, we've grabbed a filter parameter struct from the left audio filter in this case, but we want the left and right audio filters to be configured identically, so we can just set them straight up. So we can say left audio filter set parameters, and we can simply pass in the filter parameters. And we can do exactly the same for the right one. So this is it feels quite like programming in C# at the moment, which is always a good thing for me. Okay, so that's configured our filters with the GUI values, and every time we process a audio block, then we are updating our parameters in case the user changed them. Okay. So let's have a look at this code here. Okay, let's get rid of some of these comments. Okay. So here, for each channel, and we're operating in stereo, so we've got 2 channels. For each channel, we get the channel data. So we get a pointer to the location in the buffer. Okay. So in which case we can say for int input sample is 0, sample is less than so the length of the buffer. How do we get the length of the buffer? Num samples, get num samples, sample plus plus. For each of those we want to process the so what we can say is that so these are floats, so float input sample is going to be so let's think. We want we got a right pointer. We want the input data, don't we? So that's going to be the buffer. Get read. Get the read pointer for the channel. So the input sample is going to be input data. And the value of the sample. Okay, and the output so channel data, that's going to be equal, so we're going to need to, it's not right, is it? It's not right. We've got separate filters, left and right. So we want to process left and right at the same time, really. Let me think. Let's do this. We don't need a for loop round there. And we don't need a for loop in here. We're going to process all the channels at the same time. Where's the end of that for loop? So for int sample, let's just call it I 0. I is less than buffer. Oh, it was get something, get num samples. I++. Sirah, thank you very much for the follow. Let's have some electric Alf to celebrate. Thank you so much for that. That's really, really nice of you. So thank you so much for that follow. So we're now over 70% of the way to the target. So thanks ever so much. And you join us at an interesting time. Okay, so we've got input data left, output data left. Okay, so then our input sample, this is going to be a float input sample. It's going to be input data left. I. Input sample left. Input sample right. Okay. And then our output, it's data. Our input, our output data left. So this is the left hand channel. That's going to be, we're going to process that through our filter. That's going to be left audio filter, and we're going to have to call process on that. Process audio sample, and the sample is going to be input sample left. Input sample left. And output, that's going to be sample, isn't it? I, like that. And it's the same for the right hand channel. Right and right. Okay. Well, what will it do? It's fallen over. audio buffer float, get them samples. Where's that sitting? Well, it's function. Try to build it. Thank you for those that are sticking with me on this one. It's might be quite painful to watch, but this is all part of the learning process and part of me trying to transfer skills across. Okay, let's fire it up. Okay, that's our multi-filter. We've got various values here. So I'm just going to switch the. I'm going to pause the music a second. Let's put our filter here. Let's get another plugin in, which is going to be an audio player. We'll wire the audio player up into our filter, and the filter to our audio output. And then here we'll go and get a file to play, which will be one of those relax dailies. And let's play it. Can't see it's having any effect. So let's pop a breakpoint in. Okay. So we got pointers. So there's a sample. And there's a sample. So we process that through. So the input sample is going to be minus 0.077. Step over that. So that's changed it, hasn't it? It's now pointing at this 0.8. And that's 0.0049 when the input was put sample right. Sample left. Just in there 0. Interesting. Is it doing anything is the question, isn't it? Let's just stop that a second. Let's bring in a spectrum analyzer so we can see if it is actually doing anything. So let's put the output of the multi-filter. Let's get that. Oops. Come on, clear those. Disconnect all pins. Okay, so the audio player is going to play into the multi-filter. The multi-filter is going to play into our spectrum analyzer. And then we're going to play out of the spectrum analyzer into the audio input. So here's our spectrum analyzer. Let's start again. So there's our music. I can't say that's having any effect whatsoever. Let's try a high pass filter. Ah, no, it is having an effect. We've now cut off all these high frequencies, so let's bring those back. So it is working. So if we lower the Q down to its minimum, so let's try a band pass. Okay, so it's having some interesting effects on that. So different types of filters here, lots of different types. They're all quite low frequency. Let's put a low pass filter in there. So we cut everything off there. Let's make Q really aggressive. Okay, so let's stop that, and let's put in. Okay, so what we're going to do is we're going to try this out within our DAW, just through an exception. Okay, I think I'll just close this from out from under it. That's probably why. So let's give it a go. Oops, what's we got here? Let's just make sure it builds. So we're going to put this into our DAW and see, and then we're going to put a test signal through it and see what happens. Make sure it kind of filters as we're expecting it to filter. Okay. So my DAW is called Reaper over here. And what we're going to do is we're going to put in a test signal generator, which is called test tone. That's going to sit there. Then we're going to bring in our we're going to need to grab our file, aren't we? Our VST3 file. I'm going to close this again. Sorry about that. So over to the D drive. Multi-filter. Builds. Debug. VST3. Grab the VST3 file. Copy that. And then we're going to go to the VST3 folder, which is in Program Files, Common Files, VST3. I'm going to drop our plugin into there. That's multi-filter. Now we can load our DAW again. So once again, we should be able to drop the test tone into there, and then add in multi-filter after that, and then add in our spectrum analyzer. Get these various GUIs up. Okay, there we go. Okay, so we've got cut-off frequency of 1000 Hertz at the moment, which is there. There's 1000 Hertz. That's our cut-off frequency. We're currently set to be a low-pass filter, so it it should pass everything up to 1000 Hz, then start to cut away. So if we set this to a linear sweep, and we're going to set it to start at 0 and end at 1440. Okay, can you see what? So that's actually passing straight through at the moment, isn't it? I would expect it to cut off around about this area. It's not doing that. Now I thought it did initially. So, okay, our Q is very, very low. So let's increase our Q. I don't think there's any evidence of it doing anything there. Let's step it. Okay, let's try up to 10 kHz. I don't think there's any real evidence of filtering going on there, to be honest with you. Let's change the filter type. I wonder if the filter's actually working. I wonder if this filter, because it was said filter type, didn't it? Yeah, it's not filtering. Ah, now that's interesting. The high pass filter's working, isn't it? We're not getting any of the low frequencies. It's only coming in there. What we set at 4,000. Okay. So I think the high pass filters do seem to be working. Let's lower this down to 2000. So 2000 is here. It's not going to be a clean cutoff. It is a graduated cutoff. We're not getting any low frequencies being passed through, so that high pass filter does seem to be doing that. So let's have a low shelf. It's saying the same all the time, and it cuts off at 10,000 K because I think it's tell it to stop there. Probably high enough for our ears, isn't it? Let's sweep it slower. Too low to hear. Here it comes. If I put high pass filter in, It's definitely increasing at that point. So we're now cutting off about 10k. And it starts to coming down here. So before it was, so the high pass filter kind of idea is working. I'm not sure what the value of Q is, whether it's high or low Q, which has the bigger effect. So severe attenuation at this point. Still severe attenuation. We're heading towards the cutoff frequency. Yeah, so it's definitely a curve, isn't there? There's a curve going like that, which is probably what we expect. Here's a low pass. It's going down. Is it going down? Doesn't appear to be going down that much. It is going down there though, so I think we've got some low pass activity. Let's bring this into about the 2000 mark, around about here. So we should see this start to die away in amplitude. It's going, isn't it? It's going down. And there it goes. So that's low pass working. We cut the high frequencies go out. So I think we can say that that is actually working quite nicely. So here we go. Yeah. This is noise. The pink noise is redder, so that's more high frequency noise. It's definitely being cut off, being attenuated there. If I bring this down, we cut off sooner. So these low rumbles are getting through, but we're cutting off. According to this, the cut-off frequency is around about 180, 200, about there. So you can see that we get reasonably flat and then it dies away. So our filters are working. It's almost like watching a Forsen stream where the chat wants to listen to sorting algorithms. Yeah, well, at least we're proving that the filtering is kind of working. So the feedback is interesting to me. I'm not sure what the feedback is doing for us at the moment. It's normally to do with boosting a signal. So let's. So we need a resonant filter. Here's a resonating filter. So here we can see what our feedback's doing. We're getting a peak now. If we change the feedback, we should start seeing some that kind of responding. You can see it growing slight. It's only slight. And Q is basically changing the level of attack. So our cutoff frequency is about 4K, which is there where that peak is resonating. Feedback is not having a great deal of effect. Our Q is basically sharpening up that peak. Trying to resonate a B. These are all different algorithms. We've got all pass filters which take everything through. Lots of different types of filters here. So our low pass filter, you can see now, you can see with this pink noise, you can see how it's attenuating the higher frequencies. If I bring this down now, plugin, and then cuts it off completely. It's all inaudible rumble at that point. Okay, well that's at least proof that's working. So that's we can switch these off. Okay, let's start up our music again. Okay, so we got working filter, and there's more we can probably do with that to play around with it. But what we're going to do, I'm going to commit that up into our repo. Added audio filters. And we'll sync that. Okay. So let me put my book to one side for a moment. So what I wanted to do next was actually look at a delay effect. And rather than using the classes that come with FX objects initially, and we'll use them eventually, we'll actually try and do this a bit more from scratch. So let's start a new project. I'll leave this running because we'll be able to take some of the code out of here. Let's start a new Visual Studio up. In fact, we don't need to start that. We need to start up a new JUCE session. So a new project, a new audio plugin. This is going to be a delay project. We're going to call it delay. We're going to work in Visual Studio. That should be okay. We'll create that project. Yeah, we want to create right into the same file. Okay. So here we are. So let's go and set up the basic project things we need to set up. So this is going to be Codebase Alpha. HTTPS. Codebase Alpha. Live coders. .dev. Audio plugin. VST3. In fact, we're going to make a legacy VST as well. In this case, just to demonstrate the fact you can get you can do both. So this is dev.livecoders. Codebase Alpha. Delay. Audio plugin. Everything else should be okay. Yeah. So let's save that and open the Visual Studio project. So we've now got two projects down here. So it's going to build a VST and a VST2. Unlurking Rumbling Geek, welcome back. Hope you get your problems sorted. This means it's going to build a VST Legacy and a VST3, and the VST Legacy will be able to use in OBS. That might be a bit of fun. So let's set this to the startup project, and then go over to Properties, Debugging, and here we're going to browse up to our JUCE folder, and we're going to plug in host with our debugging application. Okay. We're in Team Explorer. We're going to go to Git Flow. No, the first thing we do, we're going to push these changes up to our remote. Okay. Now we're going to git flow it. So this is creating a develop branch from which we can use to actually create the our project. Standing desk ordered. You're ordering a standing desk. I don't think I could stand up, to be perfectly honest with you. But I do hear people do like to do that. I'm going to push that branch as well. There we go. So over in GitHub, we should have our initial project set up. There's our delay project. We've got a master and we've got a develop. Cool. Okay, we're all ready. So what we're going to do, we're going to build a delay, a digital delay. So we need to talk a bit about what a digital delay is. So let's get paint up and we'll do a bit of drawing. And we'll once again fill this space with grey so it looks a bit easier on the eye. Pencil, nice fat line. Okay. So when we're talking about digital signal processing, we often use things called block diagrams, and these are meant to kind of break down. They break down the kind of the algorithm into kind of functional parts, which you can start to get equations from doing these. So you are buying a standing desk then, Rambling Geek. Sit stand, okay, that's probably a good idea. Is it motorised? They're quite good, those motorised ones that raise up and raise down. Okay, so the way this is basically going to work, we're going to have our dry signal. So this is the signal that passing straight through without being delayed. Dry signal. And then we're going to tap off that. Let me just make sure I draw this correctly with my note. I don't want to get this wrong. Okay, so we're going to tap off that, and we're going to pass some of the signal into a delay unit. Now the delay unit is designated with a Z, and then a strange thing, a negative power to the Z. So if this delay unit was to delay the samples by one sample, that'd be Z to the -1. That's how you'd say that. So that's a delay of one sample. Now a delay of one sample isn't going to, the human ear is not going to pick that up. We want to delay it by a variable number that we're going to kind of dial in through the GUI. That's going to be D. D is our delay. That's our delay in samples. I'm going to get a graphics tablet. Decided. And a pen. So that's a delay in samples. So if it was a delay of half a second, for example, if our delay was half a second, that would be 22,050 samples. That'd be Z to the -22,050. So don't worry about the fact it's something to the power. It's just the way it's shown really in the diagram. Then what we're going to do, we're going to take that delayed signal and we're going to pass it back, and we're going to pass it into what's called a summation unit. So it's going to add them back together again. That's the capital letter sigma for summing. And we can put a little plus next to it to say we are actually adding them. And what we can actually do as well is we can say there's going to be a proportion of wet and dry. This is the wet signal. And what we normally do is put these little triangles on. And these got parameters on them, so we're going to have A and B there. And we're going to set it up so that that A is equal to 1 minus B. So basically, if this was 0.5, that would be 0.5. So it'd be equal proportions of wet and dry. And it basically, when you alter the wet and dry control, it'll basically just change one of these, and the other will change according to this equation here. The other thing we're going to do is actually have some feedback. So the feedback is what's going to give us that echo sound, echo, dying away echoes. So we're going to take a tap off here, and we're going to feed some signal back. Let's again do one of these things, which we're going to call F, the feedback, and we're going to add it back in to here. Really terrible diagram, but that's our feedback. Obviously, if this is 0, there's no feedback, and we can ramp it up to any value we want. The problem is with feedback, as you know, if you hold a guitar near to a loudspeaker too close, then you get lots and lots of feedback, and it self oscillates. So we're going to make sure this is less than 1 at all times. So between 0 and some number less than 1. That's the kind of design of our effect, our delay effect. Delay. Okay, so this unit here is obviously the key to it. It's something that's going to delay a sample. A sample is going to come in. So if we change colours here, we're going to have a sample which is going to come in. Let's call it X, because that's tend to what people tend to call it, the input sample. X is going to come along here. It's going to go straight on through there. X is also going to come down here. X is going to go along here. What's going to come out of this is X. So this is Xn. N is a point, any particular sample. What's going to come out is N minus capital D. X minus Xn minus D is going to come back and be fed back in. So X N minus D plus some feedback is going to be mixed back into the final signal, and then this is the signal that's going to come out. It's going to be a combination of the input sample X, the delayed sample multiplied up by these parameters here, plus something some element of feedback, which is going to go round and round in here. So that sounds quite complicated, but the crux of the matter is this thing here. It's something which delays a sample by up to quite a large number of samples. So it's going to delay. So say if we had a maximum delay of 2 seconds, then a sample 1 going in here will be delayed for 2 seconds. So what's that? That's 88,200 samples later. It's going to come out. Sample 1 will come out and be mixed in with sample 88,200. So this basically is some kind of buffer, and it's what we call a circular buffer. Circular buffer. And the circular buffer is basically the key to a delay feature. So what controls are we going to have to provide? Well, we're going to have this proportion here, the wet-dry ratio. We're going to need the feedback, F there, feedback, and we're going to need D, the delay. And we'll provide the delay in seconds, and then we'll or milliseconds say, and we'll convert it to samples inside. So this is going to be D in seconds or milliseconds, DS. And then we're going to convert it to this little d here, this capital D, which is the number of samples we're going to delay by. Okay, so that's basically the design of our effect. We'll leave that, and I can come back and refer to it. Okay. Let's go to our code. So we've got the same 4 files that we worked in the last project. We've got our editor and our processor. These are 2 processes which are going to work on separate threads, a GUI thread and a audio processing thread. And we're going to start off working on the GUI side. So let's have a look at the H file. What I'm going to do is bring the the multi-filter project up over here. I'm going to pop it over onto the other screen. There we go. So what we need is some sliders. Okay, we need some sliders. So we need 3 sliders. Slider. We're going to call this wet, dry, mix slider. And then we have a slider feedback slider. And we're going to have a delay slider. Okay, so there's our 3 controls. We go over to our plugin editor. What we can do is we can steal that code that we wrote earlier to create rotary sliders. So we'll go back over here and we had a make rotary slider method that we created. So let's grab that and pop that across in our we can make it public, I guess. No, make it private. So there's our make rotary slider, and then we can go over to, so we're just trying to cut out really a lot of the faff about making this GUI and try and get as quickly as possible to the meat of the project. So let's make it the same size. And we'll have 3 of these again. So this is going to be wet dry mix slider. This is going to be a feedback slider. Oh, that's wrong. Let's make rotary slider. Feedback slider. and we're going to have here, it was called the delay slider. So let's move these across here. So this is going to be, we're going to call this wet dry mix. This one is going to be feedback, and this one's going to be delay. Okay, this is going to be our feedback value, and this is going to be our delay value. We need to go and define those. So those come over here, and if I just grab these definitions, I'm going to put them down here. So these are slider attachments. So this is going to be called wet dry value, feedback value, and our delay value. So these are the attachments. We're attaching these delay slider, make that visible. So we need a plugin state next. That's not make Rotary slider, that's feedback slider. Okay, they're okay. And so the other thing we're missing is this plugin state. So we need to create that. And that's on the processor. So let's go and pinch the code once again directly from there. That looks simply like this. So on the plugin processor header, then we're going to have a public value, which is going to be our plugin state, which is this type, this audio processor tree values tree state audio processor value tree state. Okay. That was wet dry value, wasn't it? Let's call it mixed value and keep it in line with the slider value. Okay, that should now be happy. That should be that. Okay, let's see if that builds. Okay, so that's what we know what that is. That's to do with building the plugin plugin state, I think. Okay, here's the plugin processor, and we can once again we can steal code from our other project, because it's basically always going to be the same kind of pattern for connecting up our GUI controls to the parameters we're going to hold within the program, and also the automation parameters for the DAW. So we're just going to initialize this plugin state here, and we need to actually define a create parameter layout. Once again, this is part of the pattern that we established in the last one, which is why I spent quite a bit of time trying to get that pattern actually done. It actually helps us in the future. And we can start creating templates to do all this. So over here we can have a private method called create parameter layout. It's exactly the same as what we had before, and then we can create that over here. And then we can go back over to our plugin processor and we can pinch the code again. So I'll just talk you through the code. I'm just going to copy it into here. Oops. Copy it over into here. Okay. So we're going to create, first we're going to have a vector. It's a pointer to a pointer of type range audio parameter called audio params, and then we're going to kind of basically add to that array, add that to that vector all of our audio parameters, and then push them back, and that's going to create this layout here. So we only need 3 so far. So there's going to be a wet dry mix param, a feedback param, and a delay param. And it's going to be called wet dry mix. I think that's what we called it. Feedback and delay. Let's just pop back and make sure these values are what we set up in the editor. Wet dry mix, feedback and delay. So these got to be the same. So we're probably going to be better off doing something a bit easier to remember than that. So let's see what we can do about that. In our plugin processor, can we do hash defines in here? Define feedback. And define delay. And we should be able to then use those. What's it complaining about? Expected an expression. Don't understand that. Why does that not like that? It expands to what I expect. Is it supposed to be a string? It's never that, is it? Anyone know why that's not what it's expecting at that point? change it back for now, and then we'll figure that out later. It's a shame. But did that just to work? Okay, fair enough. Feedback. So this was wet dry mix feedback and delay. So the delay we're going to make from 0 to 2 and defaulting to half a second. Feedback is going to be 0.0 to 0.98, so less than 1, and no feedback by default. And the wet dry mix is going to be 0.0, and it's going to be a float, not an int. It's 1.0, and we're going to default it to 50% of each, so 0.5, so half and half, half wet, half dry. Let's then push these up into the vector, and that forms the parameters that we're working with. So all that code is basically, it's almost boilerplate code that we can kind of copy between different projects. So each of our parameters is defined here. Okay, these are the parameters. We've got a parameter called wet dry mix param, feedback param, delay param, and then over in our editor we've defined what's it complaining about? Oh, gone back once too many. Over in our just change that. Over in our editor, what we've done is we've created a slider, and then we've basically linked the slider to the parameter. Through this pointer. Come on, you'll build now. It's wet dry mix value, isn't it? That's why it's not happy. Okay. That's better. What's it complaining about? Dear me, what's going on now? Cannot open include file. Did I forget to include my module? I think I did. Let's close this down, start again. Hopefully now my objects should be in. So JUCE modules, fix objects, yeah. Let's try rebuilding and see if that sorts that build issue out. Can I open AEffect.h? The VST. Well, let's get rid of that then. Let's close this off and get rid of the VST2 project. It looks like I'm missing a SDK for that. So let's go into here and remove the legacy. Let's try building that now. I'll have to download the legacy SDK from somewhere. I'm sure from the Steinberg website will have the legacy SDK on it. So we should build this time. Oops, no we don't. Unresolved external symbol private class audio process tree set parameter layout. Make rotary slider. I thought I'd set that up. Make rotary slider. Didn't define it. Didn't define it, did I? Okay, so this is just me being a bit silly, but I've forgotten to create a method called create rotary slider. We'll just grab the code from the other project and just pop it down here. Okay, it's called delay. Let's try building now and see what happens. Okay, so now it's another external unresolved on private class audio processor value tree parameter layout. Create parameter layout. I thought I did create parameter layout. Obviously not. I'm sure I did. That's over here. Oh, that's why. That should be. I need to put a delay. What was that? Sorry, I've got some code over the screen over here. Anon, thank you very much for the follow. Yes, have some electric elf hype. Thank you so much for that. We're just having a little bit of a struggle at the moment, but I think I know where we're going. I think it should be that. So I'm learning C++ as we go along, as well as learning the JUCE framework, so that's why it's proving a little bit of a struggle. Okay. we should build this time. Make sure we get the right place in our code. There we are, we're building okay now. Right. So what are we going to need to be able to work with this? We're going to need to do the GUI, aren't we? So in the resize, so let's go and once again we'll just pinch the code out of the multi-filter project, so we haven't got to concentrate too much on the GUI side. So we'll just grab this code here, and we'll pop it into the resize method. So we're getting the grid. We'll get rid of this top row, just one row. So forget about that plugin name. So we've got some controls. So we got the dry wet, the feedback, and we've got the delay. That should be enough. So let's run that. Let's build and run that to make sure we get a GUI. And we've got to get rid of this hello world as well. Now we need to change these values here. Let's make sure we got a GUI first. So we can get rid of that, and we can bring in our. We need to add our plugin location. So we'll add into there. Dev delay builds PSD3 scan, and we got our delay in there now. So we should be able to create a delay. Double click it and see our. So we got a hello world in the background, and we need to figure those things out. But there's our 3 controls that we need so far. We'll need some more controls later on. Let's just save that configuration. Let's delay. And we'll save that to documents. Okay. So let's fix these up. So this is wet dry. Ratio, and the feedback is in decibels, and then we've got delay, and we'll have that in seconds. Is that what did we set over here? Yes, between 0 and 2 seconds. Okay, and we can get rid of hello world, which is that bit. That's all left over from the basic project that we built. Okay, so that should be the skeleton of what we need. So let's go over to our plugin processor. Let's think about what we need. We need to know what the delay time in samples is. If we go back to our drawing, we're going to provide this value, but we need to work out what our delay time in samples is going to be. So let's have a variable, a member in the plugin processor. It's going to be private, and it's going to be a float, and it's going to be delay in samples, and we're going to have to calculate that. So we'll start off, we'll set delay in samples to 0 in the constructor. So in fact we can initialize it in the initialization list, can't we? Delay in samples, zero. We need to put brackets around it, don't we? Like that. Okay. And then in our prepare to play, which is here, we need to say delay in samples is going to equal sample rate multiplied by, now we need to get the value of our parameter. So plugin state dot get raw parameter value, and it needs to be the delay. Okay, that should set that. Okay. We're gonna have a circular buffer. So this is what this is going to be, a circular buffer. So basically it's going to be a buffer like this, all the cells around it. It's a terrible drawing. We're going to read values from this location here, and we're going to write values into a location which is going to be a distance of D further ahead. So as we're reading here, eventually after we've gone through D, a delay of D, then we pick up the value that's written here. So this is going to be that value is going to go into there, and eventually as time goes by we're going to read it back from there. So our read head's going to be here, and we're going to have a write head. We're going to have a write head here and a read head here. So we need to know how big this buffer is going to be, don't we? So we said the maximum delay was 2 seconds. So let's have int delay buffer size. Over here, delay buffer size going to be 0. And in our prepare to play, we need to reset the buffer size depending on what the sample rate is currently. So delay buffer size is going to be equal to the sample rate times, and 2 is our maximum, times 2. So our buffer is going to be 88,200 samples in length, but it's going to be circular. That's how we're going to set it up. Okay. So we're going to want 2 circular buffers. We're going to want a left-hand and right-hand buffer because we're dealing with stereo. So this is obviously a there's a left-hand channel and a right-hand channel coming in. There's going to be 2 of these buffers inside here, 2 circular buffers. So we need 2 circular buffers. So over here we need what do we need in here? We need a pointer, a unique pointer, type float is it going to be? And that's going to be left delay buffer. And the same for the right. Okay. And then over here, in fact we can do this in the constructor as well. Constructor initialization list. Left delay buffer equals a null pointer. And right delay buffer equals a null pointer. No, not equals that. We'll get used to it eventually. Seems a bit odd, but there we are. Okay, so that's initialized those to null pointers, and then down here. Now down here, what do we want to do? So if left delay buffer the null pointer, then what we want to do, we want to size it, don't we? So we want to say that left delay buffer is it going to equal to, we're going to make a pointer, make unique. Why string and not stud string? Yes, string is a JUCE class, fuel stable. So we could use std : string, but everywhere that JUCE is using a string, it's using its own class. That's why I'm using string. So this is going to be is it float? Is that how it works? Like that? Oh, sorry. How do we size the array though? What is a vector? How do you size the vector? How do you make it? How do you set what the size of it is? It's got to be I want it to be a fixed length array, basically. Reset. Okay. We'll try using unique pointers, and then if I get into trouble, then I'll revert to what you suggest feels stable. So where were we? So I think on this over here, this should be to a float array, shouldn't it? Like that. And then over here, where are we? What did it say in that? Why wouldn't it equal it? Make unique. Using new in it there. Is that really how you use it? I'm not sure I want a vector. Vectors are like a list that grows, isn't it? I want a fixed length array. I don't want something that grows as I put things in it. Pure Naval. I'm pretty sure that's not what I want. So I think a vector is like a list, isn't it? In C#, it's going to grow as I put things on the end of it, and I don't want that. It doesn't grow if you don't want it to. So they're vectors. Then over here, I can't set them to the null pointer. Don't have to initialize them. Okay. So down here I want to size my vectors then. Left delay buffer. So how do I set the size of my vector at that point? I also want to make sure they can take .resize, yeah. So I can then set that to my new size, which is going to be my delay buffer size. So how do I make sure then that they're full of zeros? They haven't got junk data in Pure Naval. Or do they get initialized automatically? Initialize it to 0. That's excellent. It's just what we want. Okay. So what else do we want? We need a write head and a read head. They're going to be floats. No, they're going to be ints. Okay, so we need to initialize those up in our initialization list. And our right head is going to be at 0 to initially. And down here we need to set our right head it's going to be 0. Okay. So what's the next thing my notes say to do? Okay. So we need to go now look at the blocks, the audio block process. Let's get rid of these. Okay, so this is going to be similar kind of stuff to what we did before. So we don't want to step through the channels separately. What we want is left channel, left channel data, and right channel data. That's right. Okay, so once we've got our read heads, sorry, our we need to align this. We've got our read pointers, read and write pointers. So I did delay time in samples. And that's going to be equal to we should have get sample rate as a method. Get sample rate multiplied by the delay parameter, which was plugin state dot get raw parameter and that was delay. And that's a function, get sample rates. Okay, so now we want a for loop. I less than buffer dot get num samples. That's the number of samples on the buffer. I++. So this is similar to what we had before. So let's just lose this comment here. Okay. We need some feedback values because we're going to have to multiply by feedback, aren't we? So delay buffer left. Is it left delay buffer? Left delay buffer. That's going to in position I. No, position of the right head. So we're going to write in our. We're going to write our delay sample in at that position, the right head position, and we're going to. That's going to be equal to the left channel data sample I multiplied by the left channel feedback. And we haven't got a left channel feedback yet. We want to the right. I think that's right. So we need our left and right channel feedback values. They're going to be floats. They need to go into our over here. And equivalent for right. Right channel feedback. Left channel feedback is going to be 0 to begin with. So this is the right. Okay, and then we need to set our feedback so that's going to be plugin state, get raw parameter, and that's going to be feedback. We'll set the right, channel feedback to the same for the moment. So we're going to have equal feedback left and right channels. So we've written our delayed values back. So now we need to advance the right head, don't we? My notes are not clear on this. No, the read head needs to be delayed. That's going to be equal to, what's the note say? Yes, so it's going to be the right head minus the delay in samples. And then we need to say that if the read head is less than 0, so it's circular, remember, so then the read head we're going to shift it to the other end of the circular buffer, delay buffer size. I think that's right. Now we need to read. So this is popping as the value comes in. We're writing it onto the delay buffer at the current location, and then we're reading. Our read head is going to read. It's going to read behind. So our read head is always going to be delaying samples behind the write head. That's right, isn't it? So left delayed sample is going to be it's going to be the circular buffer. It's going to be the buffer left delay buffer. Reading at the read head position. And that's going to be, because that's a float, we want to static cast that to a, oops, to an int. And then we're going to get the right sample as well. And this feedback values are wrong. Then those feedback values need to be calculated down here once we've got the sample. So we want to multiply that by the left delayed sample, and that by the right delayed sample. And then we're going to have to increment the write head. And then we're going to need to test the write head. If the write head is greater than the delay buffer size, then the write head minus equals delay buffer size. And now we need to change the sample. We need to update the sample. So buffer. So there's a set sample. So what does set sample take? It sets the channel. So this is the left. And sample I is going to be equal to, so what is it going to be equal to? Oh, it's hard to work this out. So it's going to be the buffer. Yeah, so it's going to be the buffer. So buffer get sample. 0 and I, and we need to multiply that by the wet and dry. Okay, so let's think about this carefully. What we're saying is we're going to set the sample in channel 0, position I, to the value given by the dry sample, the dry signal, which is the input, what we came in, the sample at 0I, left channel I thing, multiplied by the wet dry ratio. So it's going to be 1 minus the wet dry value. So let's get those values up here. Wet dry ratio is going to be equal to plugin state dot get raw value get raw parameter value of wet dry mix. And then we're going to add into that the delayed sample multiplied by the wet dry, because that's the wet sample. So that's going to be a left delayed sample times wet dry ratio. And just put brackets around them so it's clear. God, does that look right? I think it looks right. And then we want the right hand channel. Right delayed sample. Does it build? I think some refactoring can be done in that lot. Alrighty then. Let's see what happens. Vector subscript out of range. Let's put a breakpoint there, see what happens. 88,200, 88,200, that's what I'd expect them to be. Let's pop a breakpoint in. I've obviously made a logic error here somewhere. Let's put a breakpoint in there. I believe the size of our vectors is correct. Let's continue. Hit here. Delay in samples 24,000. Sounds reasonable. 2 seconds. Oh, half a second, wasn't it? 24,000. Like that. What's the delay parameter? Only 4,000 doesn't sound right. Okay, we've got pointers there. Right head 0. Vector subscript out of range. It's maybe not in my program by the look of it, is it? It's not the code I've written by the look of it. Interesting, that's in the wrapper. Oh, it's in the vector. We went outside the range of the vector. I thought we protected against that. So if the read head, if the read head goes above though, isn't it? If the read head is always behind the write head. The read head is always decreasing. If the read head is less than 0, that goes negative. then just try setting that to 0, see what happens. Oops, needed to rebuild that. It fails again. Okay. It reached 71,999. Which is fine. Right head is there. Interesting stuff. I wonder why it's not working. Don't like leaving it like this. So it hit 96,000. The right head hit 96,000. How's it done that? Delaying samples is that. That seems right. The read head is behind. Pop those things there and run it again. Those sizes didn't seem to add up then. Delay in samples 22,500. That's correct. So that's half a second of delay. Buffer size is 88,200. So let's make a note of these. 88,200. So we get to here. The right here is position 0. Buffer 96,000. How's he got 96,000? Why have they suddenly become 96,000? Left delay buffer, right delay buffer. Why have they grown? There should be 88,200. Bye bye. Okay. We got some idiot who's decided to spam me well of it. Anti-aware, thank you for the follow. Thank you very much. Why have we got idiots joining the stream for? I already don't know. Oh well, let's see what we can do here. I'm running out of time. It's 12 minutes past 12 here, so I think I may have to leave this in an unsatisfactory state. I'm a bit kind of confused about why the delay buffer size is suddenly gone to 9. The delay buffer size is not 96,000. Why has the delay buffer size changed? Delay buffer size is initialized to 0. In prepare for play, delay buffer size is equal to twice the sample rate. Delay in samples is changed as well. Let's comment that out for a start. Pop another breakpoint in. Meant to rebuild. Let's try again. Over here. $96,000. Why is it not? And that's 24,000, and that's not right. It should be 22,800. 22,050 surely. Source Goose, thank you for the raid. Good to see you. Let's have some hyperspatial hype. We're in a world of strangeness at the moment with our C++ program. So I'm building a delay effect, a VST3 delay effect. Figures that I'm setting up to start with are coming in correct into here. So I'm configuring our delay in samples and our buffer sizes and setting our left and right circular buffers to the correct size, but they seem to be growing. They're changing. And I'm not sure what's going on. Hiya, how's everyone? Source good, how are you? Getting very late here, getting tired, and not able to intuit what's going on with the code. Delay in samples has changed, and the size of my vectors, my circular buffers, has changed from when I go into here. So let's just run it again. So I should hit prepare to play. Oops, I think we've missed it, haven't we? Let's stop. Run again. So I hit here. Delay in samples 22,500, exactly what I wanted. Buffer size 88,200. Size my buffers. Left is 88,000, so that's fine. We go into the very first and they're correct size still. And we come into I'm in prepare to play loop. And when we hit here, there's suddenly 96,000. So somewhere they've changed, and I don't understand how they've changed. $96,000. There should be 88,200. Bit of a mystery. Just trying to figure out issues with buffers as well. It's pretty late here. Yes, that's the problem. 181. Thank you. I'm not sure that's going to make an awful lot of difference, but we'll give it a go. thanks for this face for spotting that. It's 96,000. Right, I think I'm going to have to rather unsatisfactorily leave it at that because it is too late for me to figure this out, I think. That's our block diagram of the effect we're creating, so it's a delay effect with feedback. So I'll lose that. I'll draw it a bit nicer for next time. Very unsatisfactory. Okay, well I'm going to have to stop at that. Thank you, Fetchy's Face, for that observation, but it wasn't actually the issue. I didn't think it would be, but it's good to get that tidied up. So thanks very much for that. Okay, so let's. I'm going to just commit my code. Episode 44. But I shan't push it to GitHub until we sort out the problem with the code. Commit that. So that's on my develop branch. And I think I'm going to see if we can find someone who might be around to raid. I don't suppose there will be anyone. Let's see if there is. Who's this here? Pseudo Kid.
Stallion skin for the brand new weapon, the L-Star.
So we'll go and raid Pseudo Kid, and if he's still actually broadcasting. So thanks everyone who stuck with this. This very much a bit steep learning curve for me kind of stream. This is proving quite hard to do live on stream, so I do apologise for stumbling through these things. And when you get to these kind of debugging situations, I'm not sure exactly what's going on there. So do stay on board for the raid, otherwise I shall see you again at some point during the week. I'm not sure exactly when because I'm currently on vacation, so normal stream times will not apply. So take care everyone, and I'll see you again next time, and enjoy the raid.